Hey, Gabriella. Hey, Gabriella, I think I hear you now. If you've said hello, I have not heard you.
Oh,
There you are. Just can hear you now. I see you sent over a chapter 5 test review.
yes.
All right, and looks like you started some of it. Maybe question 1,
Yes.
A, and then do we need to do 1B? Oh, you did 1B already, I guess. Or not.
I did B.
Okay. So we're on to number 2.
Yes.
All right, let's look at number 2. I guess I'll snip it all in. And then I'll share my screen and we'll get started. As always, thanks for booking. Glad to help here. Looks like you got a test maybe as early as tomorrow.
Yeah. I have no idea when it's gonna.
If you just speak up just a tiny bit more, I just can't quite hear you, but
Okay, I think
there
that's
you are.
with my mic.
Yes, perfect now. Whatever you just did there, either speaking louder or getting closer, whatever that did was helping. So Joaquin has $1,000 to invest. What rate would be required to double his money in 5 years, compounded continuously? So there's actually no such thing as continuous compounding, but they do it in this class. But in real life, you never get that. That is the formula. It's not really the interest formula. It's the compounding formula. So I don't know. I don't really know what your instructor wants there, but write the equation to solve for R, the interest rate. I'm just going to kind of jump to how to do this particular question. So he starts out with $1,000, or she. Joe, I don't know what the person. Okay, that doesn't matter. And then if it doubles, A is 2,000. All right. So we have two numbers already. Okay. And do we know anything else? Yes, we know that the time is 5 years. So you try to identify the variables you have, and then you substitute them. So we know that 2,000 equals 1,000 e to the r times 5. Okay, and our goal here is to solve for r, and that's kind of what they're asking for here in part A. So to solve for r, you're going to divide both sides by 1,000. So you get 2 on the left equals e to the 5r, just reordering that. You undo e with natural log. Okay, so on the left, it's the natural log of 2. On the right, this exponent, it basically comes out in front. This natural log undoes the e, so this becomes 5r. And then you divide both sides by 5. So your r is equal to the natural log of 2 over 5. And that's your answer. You do have to use a calculator to get your final number. If you need help with that, let me know. Otherwise, I'll just get you the answer for that over here, and you can compare to what you have. So 0.1386.
Yeah, I got the same thing.
Great. Now part B, we can do part B. Part B is just to give the percentage, which is to 1/10%. Let me get that snip in. This is a decimal. So the real world doesn't work in decimals. They work in percents because I guess adults don't like decimals. But when you go to a bank, usually you see things in terms of a percentage. So you take that number and you multiply by 100. It's the same as moving the decimal place twice. So it's 13.9% because it's to the nearest 10th. Is that okay? Is that all clear?
Yeah. Perfect.
Now on your exam, I'm just going to make a small point here. They might say double, they might say triple. Whatever they say, they actually don't have to give you that number, because if it's doubling, whatever P is, you just double it to get A. So Like, let's just say you start with $100. What would A be? 200.
Mhm.
Okay. What happens when you take 100 and divide 200 by it? You end up getting 2 for double. If it's triple, that's 300. So then you get 3 for that. So the point is, they don't actually have to give you the money amount. And sometimes they don't on the exam. They just ask what would be required to double your money in 5 years. And you're
Mhm.
like, what's P? What's A? Well, you have to pick values for those.
Okay.
Depends on whether it's double or triple and so on.
Okay.
Okay, so that was kind of an overshare on that, but you may find that comes up there on the exam. Okay, moving along to question 3. Solve this thing for x. Okay, so clearly you're allowed to use a calculator, at least on this page. All right, to undo 10. Or I'm sorry, really it's this. It's to get a variable out of the exponent. You either use ln or log base b. So we used ln in the previous problem, but this time we're going to use log base b, and your b this time is 10.
Mhm.
Okay, so you write log base 10, which is independent of this. Then we write 10x to the minus 1 equals log base 10, 1042. It's 10 because that base of the exponent is 10.
Mhm.
Now on the left, like, these undo each other. And if you want more explanation on that, I can provide it. But the net result is you just get x minus 1 on the
Mhm.
left. That goes away. On the right, this is a number. It's a something you're going to put in your calculator. But you generally want to wait until the to do. We're going to add 1 to both sides. So x is equal to log base 10 of 1042 plus 1. Now, if you have a calculator, log base 10 is the same as log. But if it's base 9, then it's not. But log, it's just not written as a 10. But this is not the same as ln. Okay, so if you got a calculator, go ahead and calculate that. I'm going to do this here as well. And I get x is 4.0179.
Okay, yeah, I got the same thing.
Great. 3 decimal places. 4.018.
Mhm.
Okay. We didn't do number 1, but let me know if you want me to do any explanation on that. It's a different formula than number 2. It's the real one that actually is used in the real world.
I just want to know if I did that correctly.
Let me check. And I'm gonna yeah, let me just do the calculation here. So total value earned, so $2,000, what you started with. It's compounded daily, 0.063 over 365, right? To
Mhm.
the 365, yep, times 4. Usually the formula is pretty easy to enter. It's just a matter of like you got the formula. I got a different number for the I got a different final answer. So my guess is, let me just snip this in,
Mhm.
is that you did not put in your exponent in parentheses. So
Oh,
this has to be in parentheses. If you don't, you may have just multiplied by 4. So 1a is actually, get this right here, 2,573.14.
okay, yeah, I got that now after I put it in parentheses.
Yes, great. Okay. B, you have the right answer, but maybe not for the right reason. Oh, okay. I see what you, yeah. So B is your answer to part B is correct.
Mhm.
And then what you're doing is you're comparing that value to what you're comparing this number to this number.
Mhm.
And since 1a is bigger, that's why daily is right.
Yeah.
But you were comparing it to that number, which is way too big. So that's why I said kind of right answer, maybe not for the right reason, but it is correct. So if it said semi-annual, what is the value of n?
Semi-annual, that would be 2, right?
Yep. Let's try another one. Weekly. How many weeks are in a year?
Oh, we didn't do weeks. I don't remember. Isn't it like 50? Yeah, 52.
Yeah, you got, and that's why I'm just checking real quick. So you kind of got them all here. Quarterly is 4. Daily is 365. Okay, you got it. Great. Okay, page 2 is probably not calculator. Do you agree with that, or do you know if you'll be allowed to use it for both?
I don't know.
Okay. It's not needed, but I mean, you're welcome to have it out and use it. And has your instructor given you kind of like calculator, no calculator parts yet?
Yeah, she has. It hasn't been like very like strict though, but it's mainly just been like calculator parts.
Okay. All right. So just graph the function by hand and analyze log. There's no base, so we assume it's base 10. X plus 2 minus 3. So there's 2 transformations here. The first transformation is this x plus 2. And it's kind of like a quadratic. It's the opposite of what you would think. Because it's plus, it moves left 2 units. Okay, and then the next one is this minus 3.
Mhm.
So the minus 3 is down 3 units. Okay, so a normal natural log has like only one point kind of interest, and it's right there at 1, 0.
Okay.
Okay, so that's the point you've got to move left 2 and then down 3. That's the first thing. So the base function y equals log of x. That's the point there that we get. It also has a vertical asymptote at 0, which I know is not that hard to see the way I've drawn this, but it's at 0, there's a vertical asymptote. So that moves left 2 units as well. So this new one has a vertical asymptote at -2. Okay, and so the original looks like this. Okay, and then the transformed one, I'll do in another color here, blue. It looks like this. Now there's some things here that maybe are deceptive. This black line actually goes to positive infinity eventually. It just moves very slow. This blue one also goes to positive infinity, but again, it moves very, very slow. So it actually crosses the x-axis way out here at like 998. So pretty far out. If you would like, I can show you that on another tool, but I'm asking you to believe me as well. So a lot of this comes from like, do you understand like what's going on with the original, and then how does that affect that? So what I'd like to do, and I hope this isn't too confusing, I'd like to do it for the original in black. So for the log of x here, so the domain of that is 0 to infinity, and the range is -infinity to infinity.
Mhm.
It's always increasing. The black is always increasing on its entire interval, and it's never decreasing, because decreasing means it's going down and to the right. This is never happening. And the vertical asymptote is at x equals 0, and this does not exist. Okay, so now we're going to do all of this in blue to talk about the transformed one. It's very, very similar here.
Mhm.
So the domain, the leftmost value of the blue one is over here at, this is x equals -2. -2 is the leftmost value. See where that x plus 2 is 0?
Yeah.
And that goes to infinity. The range is unchanged because I told you, well, it goes down forever and this thing goes up forever, even though it doesn't look like it. It
Mhm.
actually goes up, crosses, and keeps going. The increasing is, it's always increasing. It's always going up and to
Mhm.
the right. That's what increasing rate means.
Yeah.
Decreasing is never, because it's never going down and to the right.
Mhm.
Okay. And then the vertical asymptote is at x equals -2. Again, that comes from this x plus 2, wherever that equals 0. And then the horizontal asymptote does not exist. It never exists on these.
Okay.
Now, there's tons of other transformations. This is just one possibility. So take what I'm saying and understand that, like, if I were to give you a different set of transformations, a lot of these things could change, but this is kind of the vanilla, boring, basic ones that you might see.
Okay.
May I move to number 5, or do you have some follow-up to that question?
No, I think I got it. We can move on.
I think you told me in the past your tests are very similar to this.
Yeah.
So I'm hoping you get, just different numbers.
Yeah, probably.
All right. Use the property exponents and logarithms to expand the expression completely. So what I'm going to do is write the property on the right and show you what happens on the left. So the first one is log A over B equals log A minus log B. So in your example, A is this little c, and your B on the bottom is this w to the power of k. So this becomes log little c minus log w to the power of k.
Mhm.
So the top's there, the bottom's there, minus between them. The next property is if you have log x to the n, this equals n log x. This n, whatever the exponent is, comes out in front. This k is going to come out in front. Log c minus k times log w. Okay. There's only one more property. It does not apply here. And I'll just write it up here. Log a times b equals log a plus log b.
Mhm.
But it doesn't apply in this particular example. Maybe you saw those in homework. And maybe we'll see them in the next problem, which is likely, nope, it's not. Okay. Any follow-up to these? Because this is done. This is
No,
the,
that was I knew those. I just needed like a refresher for that
of
one.
course, yeah. Not too difficult. Students like them. They're giving me more of those on the test.
Mhm.
Okay. All right. So solve this. So you're gonna use properties of log, ln, and exponents to do this.
Okay.
So here you want to isolate the ln of 3 minus x. So you want to isolate that. So see how you're adding 16 on this side. You want to subtract 16 from both sides of the equation. Like you're used to when you solve, you know this, right? You undo addition and subtraction first. That's why we undo this. So this is natural log 3 minus x equals -7. Now, how do you undo ln? Do you remember that?
Does you just multiply it to both sides?
You use this e. Remember that from
Oh,
class. E both sides. So like this is wrong, but you e both sides.
yeah.
Okay, you can write it. Don't say that, but it is what you're effectively doing. The e and the ln cancel, so you're just left with 3 minus x equals e to the -7. And this is a number. Like you're going to put that in your calculator and get a number, but we're just trying to solve for x. Okay. Now, whenever you're subtracting x, and they don't teach it this way really, but you really want to add x to both sides,
Mhm.
and then you want to subtract this e to the -7 over here, and you're effectively just swapping positions. So it becomes 3 minus e to the minus 7 equals x. You can subtract 3 and multiply by negative, but you end up with some other issues here. If that's clear, I would ask you to try that, where you move the x over, okay, you move the e over, so they effectively change positions like that. So this is your answer. Now you can definitely put that in your calculator, but you don't need to. Like that is done. And that's why I asked, is this calculator or not? Because you don't need a calculator. This is called like a symbolic answer because it's correct. I mean, but what we want is like, oh, let me put it in the calculator. Let me get something else out. But it truly is correct as is.
Okay.
So moving on to 7 now, is that okay?
Yes.
All right. Now your instructor is being pretty kind here to ask you about extraneous solutions.
Mhm.
You see that on the right here. So what that means is that you may get an answer that does not work in the original. So this means you need to check your answers in the original.
Mhm.
Answers in the original, not something else here. So you have 2 log base 4 x minus 5 minus 3 log base 4 x minus 5 equals 1. This one's a little bit unusual in that these are the same. Okay, because this is essentially like 2y minus 3y, like where y is all of this.
Mhm.
And I don't know if that's what your instructor meant here, but I'll show you an example on another one. But do you see that this becomes negative y?
Yes.
So it's really just negative log base 4 x minus 5 equals 1. So far, like that's our start. You undo the negative, so you move that over. So it's log base 4 x minus 5 equals negative 1. Just like in the last problem, I said, how do you undo ln? And you said e. And then here I'm going to say, how do you undo log base 4? And I'm going to write it. It's use 4 as a base. 4 here equals 4 to the minus 1. So you 4 both sides, kind of.
Mhm.
Okay, meaning like 4 becomes the base on both sides. It's this number right here that's the base of the logarithm. And just like in the last problem, so let me just scroll up so you can see that. Like the e undoes the ln, we just wrote 3 minus x. Down here, 4 undoes the log base 4. So you just write x minus 5 equals 4 to the minus 1 power. Is that okay?
Yes.
All right. So now, okay, so now you're going to add 5 to both sides. So x equals 4 to the minus 1 plus 5. But what is this? What is 4 to the minus 1? This is really 1 over 4. That's what the negative exponent means. If you have x to the minus n, it becomes 1 over x to the n. It does not become a negative number. It goes to the bottom. So that this becomes this plus 5. 5 can be written as a fraction, 5 over 1. So this is 1/4 plus 20 over 4, which is 21 over 4. Now you might think back to what I said initially, which was like, well, we're going to check this, right? When you only get one solution, you should, but it's usually when you get 2 solutions that you got to be worried about that. So there actually is no extraneous solution here. We could check this, but it's not necessary. So this is it for that. Is this okay? Is this clear?
Yeah, this is clear.
Okay, so I'm going to try and make one up here. X minus 3 minus log base 2 x plus 4 equals I don't know, 3. Okay. This is the more common type of problem that you might see. See how these are not the same inside here?
Yeah.
And like, I don't know, just give me like a minute here to explain this, because I worry that you will see something like this. We're gonna use the property log A minus log B equals log A over B. So that means this line here becomes log base 2 x minus 3 over x plus 4. So this is your A, x minus 3 is your A, this is your B, it goes down here, equals 3. Now, how do you undo base 2? You 2 both sides,
Mhm.
right? You think that, maybe even say it, but you don't in it yourself. But it effectively undoes this, but you have to be very careful. You have to do it to both sides. Like sometimes students do it on the left and they forget the right. It's like you got to do it on both sides. Like it's just like adding to both sides, subtracting, dividing both sides. Okay. On the left, it's x minus 3 over x plus 4. Yay. Okay. What is 2 to the power of 3?
That's 8.
8. Okay. It's really 8 over 1.
Mhm.
And now you can cross multiply or butterfly or whatever. You get x minus 3 equals 8 times x plus 4. Okay, and this is kind of what I was expecting. That's why I'm going through this. 8x plus 32, x minus 3 equals, so you get negative 35 equals 7x, x equals negative 5.
Mhm.
Okay, now let's go back and check this. This is why I chose this problem. Let's go back and check it. So here's the original. Grab that. Okay, log, and remember, you always go back to the original. Log base 2 minus 5 minus 3 minus log base 2 minus 5 plus 4 equals question mark 3. Check means like the left has to equal the right. It's not like manipulation. So are you allowed to take the log of a negative number?
No.
No, no. So this is no. These are both, this is extraneous,
Mhm.
even though like you got a number.
Yeah.
And that's why I was like, I don't know what I think your instructor made a mistake in either typing this or something. So
Yeah.
that's why we did this example. Is it clear the difference, because here that they were exactly the same, so we could combine them,
Mhm.
but in most cases they're not. So you end up using this property of like multiplying them
Yeah, that's
or
what
dividing them.
we used too. So
Okay.
well, I should put that one in, but
All right. Moving to 8 now.
yeah.
Okay. Use properties of logarithms, exponential logarithms to solve 9e to the 2x equals 30. So again, order of operations applies here. You undo addition and subtraction, then multiplication and division. You want to isolate the e to the x, or in this case, the e to the 2x. So you want to undo this 9 on both sides. So you divide by 9. E to the 2x equals 30 over 9, which doesn't divide. You can reduce. I mean, you can divide both by 3 if you want. It's up to you.
Mhm.
Okay, how do you undo e again? You remember
Oh,
that from earlier? ln?
yes.
Great. So you take the ln of both sides. So this is 2x equals ln of 10 over 3. Okay. Now you might start expanding this, but you don't have to, because like it's already compact right here,
Mhm.
and you don't necessarily need to.
Okay.
All right, now, and then you divide both sides by 2. So x equals 1/2 natural log of 10 thirds. And it, you could put this in your calculator. You don't need to. You're done here. This is what your instructor wants to see. Okay. 9. Go to 9.
Yeah.
Great. All right. So 9 should actually come after 5, because like normally you have an expand and then a condense problem.
Yeah.
If you look back, 5 was a expand type, and this is the backwards, like condense. So it's basically using the properties in backwards in order. So the first property we're going to use is the n natural log of x equals natural log x to the n. This is the one where you move the number out in front up to as an exponent, number out in front up as an exponent, number out in front as an exponent. So you get natural log 2 to the minus 3 power. Now it's your choice. You actually can decide here, do you want to make this minus 1/2 as an exponent, or do you want to do just the 1/2 as the exponent?
Just the 1/2.
Okay, so minus natural log x to the 1/2 plus natural log 3x squared. Okay, so that's the first property. Now you're always allowed to simplify. Okay, so like 2 to the minus 3 is 1 over 2 cubed, which is natural log of 1/8. Is that okay? Is that clear? Give me a yes or no on that.
Sorry, yes. I don't know
Okay,
if
great.
I'm listening.
All right, and then the next one here, you actually square this, you get the natural log of 9x squared. Okay. All right. Now you can either apply either one of these, but I'm going to just do it in the order that it appears. The natural log of a minus the natural log of b equals the natural log of a over b, and that applies to the first two here. So it's the natural log of 1/8 divided by x to the 1/2. We'll deal with that fraction later. Plus natural log 9x squared. Okay. So that's just a simplify. Well, I'm sorry, we're applying this step over here. I'm trying to give you the explanation over here on the right. Next thing we're going to do is apply the property natural log of a plus natural log of b equals natural log of a times b. So it's natural log of 1/8 over x to the 1/2 times 9x squared. So it's really 9x squared over 1. So that's why it maps this way in there.
Mhm.
All right. Now this may be uncomfortable, but if it's 1/8 over anything, this equals 1/8. So basically this goes down to the bottom. So this 8 really comes down to the bottom. So it's natural log 9x squared over 8x to the 1/2. And depending on your instructor, you can actually apply this exponent property. X to the n over x to the m equals x to the n minus m. So you subtract this 2 minus 1. X squared over x to the 1/2 is x squared minus 1/2, which is 4 over 2 minus 1/2. So it's ends up being x to the 3/2, like that. Is there any other questions here that you would like to do again or do similar ones, or what else would you like to do with the time we have remaining?
I have like other things, but going back to number 7, I was just looking over it. And what happened to the 2 and the -3 in front of the log?
So yeah, let me snip that in. Let me again preface this by saying in number 7, let's say I asked you, what is 2y minus 3y? You would tell me that is -1y. Well, in your problem, you have 2 log base 4 x minus 5 minus 3 log base 4 x minus 5. Your y, this is your y. Do you see how these are exactly the same?
Yeah.
It's 2 of these things called log base 4x minus 5 minus 3 of these things called log base 4 of x minus 5. So you can effectively combine them. And that's why it becomes negative log base 4 of x minus 5. You have 2 of them, you took 3 away, you have -1 of them.
Okay. That makes sense.
And it's really weird. Like, that's not usually how this happens, which is why I did that other example where you actually use the property A minus B.
Yeah. Okay.
All right. If you have some other stuff, yeah, go ahead and send it over. Let's get on it and you know, see what else you got.
I did the majority of it. But they're like similar to numbers 1 and 2, but there was like some other formula involved that got me a little
Okay.
confused. I don't know if it's sent yet. Okay, I think it just sent. Did it go through?
Yep, there it is.
Okay, perfect.
We're all so impatient, but it's it's really fast.
Yeah, no,
So I
it's
see I see 2 pieces of paper. Which one do you want us to look at first, or which problem number actually?
I didn't do number 20, so I guess we could start with that one.
All right, hang on just a second, please.
Okay.
All right, so number 20.
Yes.
I think I have the wrong one again. Okay. Yeah, so this is actually is good because it's what I was referring to in number 1, where they don't give you the amount, but you can still do this. So we're actually do B first. So doubling time. They want to know how long it's going to take to double if it's compounded continuously. So that's A equals PE to the RT.
Mhm.
Okay, and the time is what you're trying to figure out. The rate is 0.025. Okay, and you're like, well, what's A and what's P? Well, if we're interested in doubling, it doesn't really matter. Whatever P is, A is double that. So you can pick values for A and P. So let's say A is 2 and p is 1. That's the most basic one, 0.025 t. Okay. You can divide by 1 if you want, but you end up getting 2 over here equals e to the 0.025 t. How do you undo e again?
ln.
ln. So you take the natural log of 2 equals the natural log of e 0.025 t. Natural log of 2 equals e to the 0.025 t. Oops, I'm sorry. I just said that a bunch of times. The e goes away. Okay, and then you divide here. So t equals the natural log of 2 over 0.025. Okay, and that is a number they probably want this in your calculator. So let me get you that. Log of 2 divided by 0.025. So 27.73 years. Okay, now the quarterly is actually more, I think it's a bit more challenging to do. So A is quarterly. So quarterly, whenever it's not continuously, it's the A equals P 1 plus R over N to the N times T power. Okay, now your P and A are not given, but it's the same thing here. Like you want to double. So whatever P is, A is double that. Your rate is 0.025 again, that doesn't change. But this time N is equal to 4. And your T, your T is right there. Okay. All right. So this is the one that's kind of like it doesn't, it's not as kind to do. This stuff in here is definitely a number. Probably is faster to actually do it to get that number. And then well, it's got a lot of zeros. Okay, so this is 2 equals, the 1 doesn't matter anymore, so it's 1.00625 to the 4t. So the way you get the variable out of the exponent is to use ln. So it's natural log of 2 equals natural log of 1.00625 to the 4t, okay? And then this 4t is what comes out in front. So it's natural log of 2 equals 4t times natural log of 1.00625, okay? And then you're trying to get t by itself. So these, in some ways, this is 4 natural log 1.00625 times t. So you just divide both sides by that. Now, what I don't recommend would be to try to put this in your calculator every step of the way. I think it's better to do it at the end, but when you do have more than one thing in the bottom, you have to put it in parentheses.
Oh, okay.
And you get, I get 27.8, which is slightly longer than the other one. 8.1 years. You're more likely to get part B, the continuous one, than the quarterly or monthly or whatever.
Yeah, I think so. To
What's next?
which one was it? There was like a specific one. Number 10, just like the I and O part was a little confused.
Number 10. Oh, I see. Oh, I0. There's a formula for this. I guess I gotta look it up.
Okay.
Stand by here. Where's the formula? Give me just a little more time here.
Okay.
I just want the formula. Do you happen to have it from your book? It's like log base 10 I0 over I or something, or I over I0.
Let me check. I think it's 10 log I over I0.
Yes, there it is. Okay. Yep. Okay, so I got it here as well. It's 10 log base 10 I over I0. So the I'm sorry. This is not. I need more information here to be able to help you, because this is not.
Yeah.
Sorry. This is. I don't know if what they want. I think what they just want you to do here, say 10 times log base 10 9 over I0. Or they want you to say 9 equals 10 times log base 10 I over I0, and then solve for I. I really don't know. And I can't find a related question or the actual example from your book, because this is just a college algebra book or algebra and trig book that's used over and over again, but I just can't get it.
Sure about this one in class tomorrow.
Yeah. Anything else I can answer real quick for you? Verbally or.
Well, I think 10 was the one that I was maybe stuck on.
Yeah, or maybe you can just ask before class again, or
Yeah, she like didn't give us any information about that one versus the others. So I'll just ask her about that one.
okay. Well, thanks so much for scheduling. I'll send you the notes out shortly, and I'll see you next time.
Perfect. Thank you.
You're welcome. Bye now.